Hello everybody, this is Introductory Physics 1, Lab 2. In this lab I had to observe the motion of an object that is dropped from rest and falls straight down. That object is a piece of paper and these are the data selected by tracker. Then I had to model this movement by using Newton's second law. Okay, let's try to find the forces applied to this piece of paper. There is Fw looking downwards at the negative y, and there is drag force opposite to the direction of the movement looking at the positive y. So F net is given from this equation, Fw from this equation, and I used these two equations for F drag, be defined later. And then I took three cases. First case, no drag force. As a result, F net is equal to Fw. M is given, G is given, initial velocity and initial position are equal to 0, and delta t, I took this value from tracker. Second case, I inserted drag force, the first equation, I did some math right here. And third case, again with drag force, but this time with the second equation for drag force. Let's run VPython without drag force. Okay, only the weight force shown by the yellow vector, and let's run again using drag force the second equation. Let's uncomment this and comment this. Okay, here is this second equation. Okay, and let's run Python once more. As expected, there is a new vector, the drag force, that increases as velocity increases. Okay, let's compare predicted and the observed data right here. So without drag force, there is a deviation, and as expected, final position does not match between observed and predicted data. That's logical because in my model there is no drag force, there is only the weight force. Then I inserted then second case. Drag force is given from the first equation. There is a small deviation, okay, right here. And third case, again drag force, but from the second equation, given from the second equation. Again, small deviation, but not so big. This is shown better from this graph. We can see right here, if we zoom in, that the second equation applies better to our observed data, this green line. Okay, so to continue. So what does it mean? First of all, what does it mean? Terminal velocity. Terminal velocity is the velocity of a falling object when F net is equal to 0. In my case, when the magnitude of Fw and Fd is equal each other. In that case, the magnitude of the velocity has a constant value. Let's go to our model. This is the first case, where Fd is equal to 0, and this is the second case where Fd is given from the first equation. As you can see here, the velocity increases to infinite. But in the third case, when Fd is given from the second equation, it seems that at some point velocity becomes asymptotic to a constant value. In other words, the terminal velocity. What if? Let's apply an initial velocity to our model, this value, and see what will happen. As a result, velocity is transposed to some factor. This graph has initial velocity equal to 0, and this graph with a blue line, it has initial velocity this value. But we must be careful because this factor, this transposed factor, is not equal to initial velocity. Thank you very much.